Hi, I'm Pat Kelly. Okay, for this problem, there are actually two parts. Each part has a different variable, but they use the same situation. And the situation is supposed to be a spinner that's broken into three equal parts. So I tried to draw a spinner. Cut me some slack on that one. But they are labeled 1, 2, and 3. And for the first part of the problem, the variable is just what the display is after you spin it, a 1 or a 2 or a 3. The second part's going to have a different variable, but we'll address that when we get there. For each part of the problem, they ask us to find the expected value, the variance, and the standard deviation of the variable. So let's start with part A of this problem, where the variable is just what the display is after you spin it. And we're going to have to find the mean, the variance, and the standard deviation of that variable. Okay, so if they ask us for the mean, I'm going to kind of try to start with the formula. The formula for mean, make sure I know it, is mu equals x1 times p of x1 plus x2 times p of x2 plus x3 p of x3. And just writing down the formula for mean kind of motivates what work I need, maybe even a little bit of preliminary work. I do need to make sure I know each of the different values the variable can be. That's x1, x2, and x3. But also maybe a little bit more involved is the probability that would correspond to each of those possible values for x. So just seeing what's needed in the formula kind of makes me realize I need to do some work ahead of time in terms of looking at this variable of x and maybe starting with a frequency distribution. A frequency distribution, you should recall, just organizes the different values that x can be in the one column and the number of different possible outcomes that have that value. X in this first part of the problem is just what's displayed on the spinner. And there are only three possibilities, 1, 2, 3. And in the second column, we're just counting the number of ways that can happen. So how many ways can you display a 1? Well, just 1, and 1, and 1. It's fairly easy, I hope fairly straightforward, but it'll kind of help us think through the right approach for the second part of the problem. Now that leads me to the next part of my scratch work, is the formula is telling me I need a p probability for each of those x's. The frequency distribution organizes the frequency of each of those values of x, but I'm also going to do a probability distribution which organizes your thoughts in terms of the values that x can be. Again, 1, 2, 3. But also, and useful for us in this next step of our work, is the probability for each of those values of x. So I go to the frequency distribution because these entries that correspond to those values of x are the numerators for your probabilities, and the denominator is the total number of possibilities, which you can always find by adding up those frequencies in the frequency distribution. So 1 plus 1 plus 1. Putting that together then in the probability distribution, the value of x being 1 is going to have a numerator of 1 and a denominator of 3, 1/3. The next entry in the table is 2 for x. From this table, I get 1 for my numerator again and 3 from that total. It's my denominator again. Okay, and then this is also 1/3. In this part A of the problem, the variable's not too involved, but I walk you through that because it'll help us get through part B, where the variable's just a little bit more involved. The frequencies are a little bit harder to see, and the probabilities take just a little bit more thinking. But in either problem, part A or part B, I like this work so that it sets me up for my formula for the mean, because now I know what to plug in where. What I'll plug in for x sub 1 is the first value of x, which is 1. But what I plug in for the probability of x sub 1 comes from that part of the table right there, the probability distribution. So I'll multiply by 1/3 plus the second value of x, which is 2, times its corresponding probability of 1/3 plus 3 times 1/3. Okay, so trying to find the mean, I start with my formula. And then I have to know what to plug in where in the formula, and that's why I ended up doing a little bit of work over there. And now it's just arithmetic. This ends up equaling 1/3 plus 2/3 plus 3/3. Fractions, common denominators, so I'll just add across the numerators. And we get a mean of 2. That ends up equaling my mean. Second part of the part A is also to find the variance of this. So I again would start with the formula, V of x equals. The formula for variance is x1 minus mu, parentheses squared, times the probability of x sub 1 for each of the different values of x. And again, having the formula in front of you kind of guides you then in terms of what you need. Hopefully you have everything you need. You plug it in the right place and it becomes arithmetic. Having this formula in front of me, what I can see that I need is x sub 1, x sub 2, x sub 3, the different values that x can be. Mu, which was not given to us in the problem, but it was something that we worked out, so we'll need that value of 2. And then also each of these probabilities, which again is a benefit of this work that we did, so we have that table there. Now I'll plug things in. X sub 1 is 1. Subtract the mean of 2. Corresponding probability for x sub 1 is 1/3. X sub 2 is 2. Subtract the mean of 2. Probability is 1/3. X sub 3 is 3. Subtract the mean. Okay, so we had our formula. We made sure we had all the right pieces of the puzzle. We put them in the right place. And now it's arithmetic. So 1 minus 2, negative 1 squared, though, is 1 times 1/3. 0 times 1/3. 3 take away 2 is 1 squared. 1/3 plus 0 plus 1/3. Equals 2/3. 2/3 is our value for the variance. If you want a decimal, you can grab a calculator if you need it. But the 2 decimal places, it should be 0.67. You can always grab a calculator if you want. I'd really only go to a decimal version of that because we're leading now into the standard deviation. It's also asked of us to find the standard deviation for the variable. I again start with the formula. So the formula for variance is the square root of v of x. Make sure you know the formula and then make sure you know what to do with the formula. And the formula here is just the square root of our answer for the variance. This is just going to equal the square root, 0.67. As a decimal, then it's why I would take the variance as a decimal, so I can just take it in the calculator. I can do the fraction as well. Then probably a calculator to find the square root of 0.67. So we're just doing square root, 0.67 and 0.82. So we have that as our standard deviation. This is our variance, and then our mean of 2. Problem again, had that spinner with the 3 different sections, 1, 2, 3. The variable for part A was just the display on the spinner, and they asked us for the mean, the variance, and the standard deviation. So we have our 3 answers there, there, and there. Okay, a little bit more work to do for part B. Let me clear the board, and we'll get at that. All right.